Welcome to another edition of the Paradime livestream. Today we are announcing the release of the column-level lineage as a context within the Paradime Code ID, our cursor for data platform for AI-first analytics teams. Paradime co-founder Fabio will give us a demo, use cases we are solving, and some of the design choices we've made as we build this product. Paradime is now the only tooling in the market to offer column-level lineage as a context as part of the AI experience. So sit back, relax, and enjoy the rest of the live stream.
What we're going to do is we're going to go through a set of workflows, and we're going to explore how Daniel can sort of help us with that. So the first thing is we're going to use this little handy button, which is explore column lineage. And what I want to do basically, we generate this prompt, which is show me the column level lineage for this column in this model. And think about if we want to understand how this column is calculated, where is it generated from, what's the data lineage, what is the column introspection that we have. So by pressing the send button, we have AI using our column level lineage tool, and it's got a bunch of things for us. So it's now generating a diagram to help us understand what are the lineage dependency of this column. And what I really love about this is the fact that it's also, and this is important, is actually giving me a human readable explanation. So if I look at our mermaid, I can maybe zoom in. So it's actually was able to tell me, okay, the driver category is coming from these 4 upstream tables that I have there, and those are connected to various different items in place through representation of how driver's category is calculated, right? So it's actually pulling all the columns that I want there. Now, what is great about this is that it's actually helping me now to understand every single step of the transformation. So it's saying like, okay, I have this table with consolidated risk level data, and then we have some aggregation. It also tells me where it's used, right? It gives me a human readable explanation of this data flow for this specific column without me trying to understand in detail what this lineage construct looks like. So it's pretty great because what we're seeing is that it helps massively people to really understand rather than try to guess what the data flow looks like. So it's a pretty good example that I prepared to kind of like get things started. What I'm going to do now is I'm going to create a new thread, a new conversation, and we'll go with a different prompt here. So let's talk about impact analysis, for instance. So we have a column here, and we do have this is points finish calculations, which takes the top 10 drivers for that. So let's say if we want to change, we have a change in definition, and we want to understand before we make any of this change, what is the impact of it. So I can use a simple prompt like this. I don't have necessarily always to enter the column name through the inline command. So show me the column lineage for the column is point finish in the model SDG F1 results. So what we expect now is that it will be understanding this lineage dependency first for us. It will ultimately generate a summary similar to before, to what we've seen earlier, and it's kind of like telling us how important is this column, right? So a significant impact across data models. It influences various different downstream metrics as well. So it's kind of like a pretty big thing for us, right? It's like a lot of things happening on the base of these metrics. Let's say new change in regulation, we need to change from 10 to top 8 driver. So those are the one that will be calculated as driver that got to points on it, right? So I'm going to now ask, and this is what going to point cost around context and managing context, is where I can actually have a conversation about my data lineage and understand truly what's going to happen if I change from 10 to 8, right? Now, let's press send and let's see what the agent will come up with. So the idea here on what we build is to have a full end-to-end conversation so that the agent not only can help us to understand the lineage, but also understand what is the downstream impact of those changes. Easy one, single line change, we go from 10 to 8. So it's a pretty small change, but what is the downstream impact of that, right? As this gets generated, it will actually print for us every single tables and column then is ultimately referencing this very upstream at the most base level column. Exactly. So by changing that, there will be a new point finish criteria. You should expect then some of those metric will change in value. So see here, recalculated based on new criteria, you will have this race performance rating. Point finishes in this other table will also change lowering the count of drivers finishing 9 and 10. So it's a small change, just changing a number, but effectively there's a lot of downstream impact of the change. And I haven't made any change right now. It's just informed me about, okay, what is bound to happen there. When we look at the Mars layer, there's a major business impact. So I like this one because it kind of helps me understand what my user will get by me, or what my stakeholder will see by me just making the change in byte, right? So double points rate calculation will change. Latest double points might show different recent performance. Significant driver analysis changes in the Mark driver championship table. Carrier statistic will be lower. That kind of makes sense because suddenly a lot of driver, then they maybe got 9 and 10 plays. Now suddenly they have a lot less point, right? And then it goes on with business impact concerns, like what should I care, right? So it creates some discontinuity with historical metric. It makes sense because it didn't tell that it's a pretty simple change, but is there like a point in time where this change happens, or actually now suddenly both from today onwards, but also in history, I'm going to change the state of that definition, right? This I think where things get super exciting is that it starts suggesting how to best perform that change I want to implement, right? So add some variables in place here in there for the columns, historical preservation as well. So keep the logic of pre-change data constant, maybe try to think about different metrics. So it really helps me understand how going from 10 to 8, it's a simple change, but how I can bring continuity to my data models and my data pipes. So I have to say, I'm pretty excited with this. It's whenever I see it at work, I'm like, what's good? So powerful. I think this use case here, it's about, okay, I'm about to make a change. It sounds like a small change. How do I know truly what is the impact of the change without having to run any DBT command, run any query purely by looking at the lineage and the content of our data, of our column, right? Pretty exciting one. Now, I want to go through like a third use case I have prepared. So I'm going to start a new thread here again. And I'm going to go and pick a different model. And I want to look at, let's say, this column here, championship position that I have at the very end here. Cool. I want to look at this, right? So this is a analytics driver performance trend SQL. Is in my analytics folder, which means actually what I expose to my end user. And the scenario here is, I say somebody reach out to us and say, hey, I think this position metric is wrong. I don't think it's right. So how do we do that? Like we can actually go now, and I'm just gonna use this prompt here, and I just basically give to the agent these exact prompts, like, hey, think something is wrong with this column in here. Can you go to this championship column in this model and just tell me what possibly could be wrong? I didn't tell yet, what the actual problem is, but maybe the user doesn't even know. It just feels, and the data sometimes about feelings, right? You look at the number, it's like just feels a bit odd today, right? So what the agent is capable to do now is going through the column-level lineage analysis, right? And give us a very detailed version of what are the steps on where this column is calculated. So it always gives us this visual representation so we can follow through. So you can see it's a bit of a derived column here, right? So it's rejoining a bunch of tables upstream there. And it's telling us basically how the transformation work, what kind of columns have been combined into this metric. And it's kind of like pointing us now what we should investigate first. Okay, so it's basically so, hey, there is this in driver race performance. This is where the core of this transformation lives, right? So I can then go here and search for this model and look at this column that I want to check here, and we can see then there is a row number of a partition. So it really helps us to start tracking where potential the issues might be, and it gives us the option, right? So, okay, well, one is this model is where most of the calculation is, so that's probably one place where we should look at. And then it says, okay, there is a ranking, a window function that maybe some partition might be set correctly, and then it's also say, hey, if that's not the case, well, then there might be a data quality issue at the result table that is my source, right? And particularly with the points column. So really kind of driving us into how do we get to the answer to that stakeholder and say, hey, this is wrong. Can we go and check what's happening, and having the agent helping us out all the way through on identifying what the potential issue is, right? So again, super powerful a lot of users that have been using this feature already with Paradime. They're seeing incredible time saves on this collect request from stakeholder too. I'm going to start in the chat now. I want to walk you through another use case that can happen particularly in regulated industry, right? It's like we have a report, right? And we need to prove exactly where the source data is for a very specific calculation, right? So again, we want to, let's suppose that the calculation come from this table I'm pulling here, and we are looking at career points, right? So somebody's going to say, hey, how do we actually count, or how do we sum? What is career points? Where does it come from? And we have to be able to justify the whole end-to-end logic of how we build it to state regulators. So I can now give a little prompt like this. So I need to prove exactly where the source data contributes to this drive metric. Can you generate a lineage report for this specific columns I have there in this model, and press enter. So as you know, in Formula One, we have a budget cap, meaning that you can't just spend everything in there. So it's not going to go and do a bunch of things for us. It's going to scan the SQL. It's going to understand what's happening in the SQL. It's going to look at the column, and then it's going to start looking at the lineage to truly understand where this data is coming from, looking at the sources of YAML relevant to that. It's actually doing a bunch more thing of what we've seen so far, right? So it's scanning more than one SQL that is related to this specific column I'm looking at. And it's completely going on autopilot, right? It's finding all the relevant context and information that it needed to create this report for me. And now it's going about, okay, let me do a visual diagram. So it's actually generating all these artifacts. Then fundamentally, we could just take and analyze and take them to the, to a regulator or anywhere else where we might need this information. So now all this is, it's getting generated, really helping us now in understanding on our project, like where the data is coming from, how it's being transformed, what kind of moving parts and are part of the project, right? So I see, very curious now to see what the output of this generation is. So you can think about also to have this information generated and stored into, let's say, a markdown file inside your own repo as well. So if you want to kind of track and say, hey, this is how this metric has been calculated, this is where it's being generated. It's actually interesting. It's actually doing that for me already. So it's generating all these things for us. And I can click accept now here. And maybe let's try and look at this one, which is our markdown view that we have in Paradime. Is actually give us like an executive summary of this report, which columns were part of it, the descriptions of the column, the linear chain into a memory diagram. Wish I would have, get this inside the chat rendered, but it's available to us. Different step of transformation. What is the actual logic of that metrics in here? And each of the single step documented for us, right? So this is extremely powerful when we have to document, audit some of those critical, critical metrics and definition. So think about a revenue metric or cash balance metric. So anything that it's pretty important that it's truly documented and available for auditor. So we can do this super easy on the fly right away in here. So 100%, yeah. So it's ready fundamentally. Probably we want to add, that who would generate it and few other things. But fundamentally, it gives us everything, so that we can get to that meeting, get to that auditing session with all the artifacts that are needed to justify, why revenue is the number that it shows on all our reports. Yeah, totally. So from a product perspective, we've been, of course, thinking about Column-Level Lineage as a tool to get to answers, right? And in today's era, answers are written. I should not look at the spaghetti lineage with 150 columns and try to follow with my finger which columns goes where, right? Our point of view from a product perspective is that usually this visualization or those graphs at the column level, they work tendentially very well in devs when you have a few tables, a few columns in there. I think with many of the customers we work with, the reality is that tables have hundreds of columns, and a standard DBT DAG have a series of many tables, and specifically or particularly certain columns, orders like an user column. I think the classic one, everyone has one. That user is in many of the table downstream. So how do you make sense of that, right? If you ask if the request is, can you tell me how user flows through all the way to the last table, you're probably going to have a series of many tables that you have to track through. And ultimately, that has to go into a report. I mean, nobody will take a visual graph as a report, right? And I think I have, I know we're a bit over time, but, I'm pretty excited for this one too. We can give it a try. Let's see, which is now about, particularly again, within these regulated industries and the data we looked at, we have PII data. We have PII columns, right? So can we do to get a better sense of what this data is and what can we do with that and how we can use the lineage to help us make certain choices. So I have one more example in here. So I'm going to search for this table, and let's say here what I have is a driver name. Okay. Now I have a little prompt, which is I want to understand from PII perspective. So tell me about this PII call. How does it flow through? Which are the steps, right? Where this is going. So Prince Fenter here. Now I just want to kind of like get an understanding of, I think everyone has one, really a name or an address, a date of birth, and this can help us massively, I think, to actually be compliant and understand really step by step, right, where this is used. So it's okay, well, actually, it's a composite column, right? So this driver name comes from two columns upstream, which is the first name and the forename surname here, the first and last name. So it's going to help us to understand, okay, how is that PII generated, right? It's a combination of things. So there's a join there, there's a combination of columns in here. What does it contain? Where does it use? Okay, is it traceable? Yes. It's a must. So that's the first problem, right? It's like, well, we actually have a potential issue that we have this column that across all our data pipeline and it's not a must anywhere. There are multiple models. I have two consumer models. So if you go back and look at our graph here, it's actually say, okay, this here and that we have analytics and MAR. So we do have this analytics table that is consuming. It opens a question, well, if it's analytics, does the analytics team needs a name? Like what's the value with that, right? So we could, of course, go and modify these fields and this, but I can try, let's give it a go and say, hey, there's some recommendation, right? And let's say then we all agree and say, okay, the analytics name should not access that column that we should be must, right? So it's okay, can you anonymize this field when reaching the analytics drive performance trends .SQL model? So basically I want to keep it intact and just at the end, I want to apply some changes. So we can give it a go and see if we can get that, which is now kind of like looking at, I understand more about the models, I understand more about the column, I can see the driver name is there. I'll implement an hash-based anonymized approach that will create a consistent anonymized identifier. So I didn't spend too much time about what the hashing will be. I think these are the great plays, in my opinion, where, for instance, Dyno rules have a big play, which is like defining for the agent what hashing mean in our word and how we should implement those, right? And kind of like not only using the column-level lineage with Dyno to inform us about things, but also try and explore how we can actually use it to do things for us. So I'm curious to see what the output of this now will be. But we're seeing scenario like this with our customer. We're seeing scenarios where you're renaming their column, but then that column is aliased later down the line. So a simple find and replace won't work because you may be adding a suffix to that column and then you have a composite column afterwards. But you see now. Let me just close this as well. So it's using a shard to then concatenate the driver with the hash value for us and create this anonymized value in here. So I think this is pretty awesome to be able to on the fly understand where these PII gaps are based on some of the columns we have, and then using Dyno itself to implement those changes and again, giving all this information. What the beauty of this is that now, of course, we can get this report, we can use this report and use some of the other feature we have in Paradime, might generate a pull request description. So all these additional artifacts that we generate as part of our work, we just send it to GitHub and say, hey, this is the change I've made. This is why I made it. All this information can be made available for auditing purposes. And I think this is where column-level lineage using AI become extremely powerful for all these other use cases, which is not about finding where the column starts and where the column ends, but enriching our workflow with these capabilities That will just make our life easier. And, you can think about ultimately all these columns have a starting point, right? Which is your sources. I can say, hey, Daniel, go and look at all my sources of YAML and using the Snowflake or BigQuery data warehouse tool actually fetch columns from my databases. And so can you tell me which of these columns should, be anonymized at source, right? So you can start, I think that's the beauty of Daniel tools we build, that you can actually compose those experiences, right? So you can use the lineage tool with the data warehouse tool, with the search tool, with, maybe, there will be a Jira ticket somewhere, and we can just use the get Jira issue tool to just pull all the definition of what needs to be done and tell Daniel, hey, this is your task. This is the tools you have available. Just go and complete that task for us. Thanks, Gustav. This was great. And catch up soon.